Gay-Lussac's Law. Brought to you by Have you ever made your lamb stew or delicious pulled pork in a pressure cooker? If you have a pressure cooker, you already know that it saves you a lot of time and money. And here's why. Take the sample of gas and enclose it in a container. This gas container now has a fixed mass as well as a fixed volume. If I stick a Bunsen burner beneath this container to increase its temperature, this gives the gas particles more kinetic energy. With increased kinetic energy, the particles can collide with the container's walls more frequently and with more force.
Since pressure equals force divided by area, an increase in overall force applied to the container's wall will result in an increase in the pressure inside the container. As a result, we can deduce that a gas's pressure is proportional to its temperature. Alternatively, we might state that for a given volume of gas, pressure divided by temperature is always a constant. As a result, dividing the initial pressure by the initial temperature equals dividing the final pressure by the final temperature. This is one of molecular kinetic theory's three gas laws when plotting a graph of pressure against temperature. It's a simple linear graph to demonstrate constant proportionality.
Back to the pressure cooker. A pressure cooker is more efficient than a standard pot since it keeps the volume constant. It keeps the liquid inside the cooker instead of allowing it to rise by locking the lid in place. If the pot's lid lifts, as it does here, some of the energy is used to increase the volume in the fluid rather than all of it being used to raise the temperature and pressure.
Now, we'll be showing you two situations where you can apply Gay-Lussac's law. Example number 1, the tire pressure of a car is 19 psi at 15 degrees Celsius. What will be the new tire pressure when the temperature of tires increases to 32 degrees Celsius while driving on the road? First, let's establish our values. P1 is 19 psi, T1 is 15 degrees Celsius, and T2 is 32 degrees Celsius. We must use the formulas below to find P2. To begin, we must convert Celsius to Kelvin, which may be done by simply adding 273 to the given Celsius. So T1 will be 288 Kelvin and T2 will be 305 Kelvin. After that, we must substitute the values into the formula given below, and then cross multiply. The answer will be 5,795 psi times K equals 288 K P2, then divide both sides with 288 Kelvin. And for the last step, just simplify and divide. The final answer will be P2 equals 20.12 psi. So the new pressure will be 20.12 psi.
Example number 2. The pressure of a gas in a rigid container is 150 kilopascal at 300 Kelvin. What will be the new pressure if the temperature increases to 1200 Kelvin? To calculate the new pressure, we use the formula above. Then, we identify the given values. P sub 1 is equal to 150 kilopascal, T sub 1 is equal to 300 Kelvin, and T sub 2 is 1200 Kelvin. Now we're going to calculate the new pressure, which is P sub 2. We substitute the given values in the formula above and then cross multiply. Our answer will be 180,000 kilopascal times K is equal to 300 Kelvin times P sub 2. Then we divide both sides by 300 Kelvin. So for the last step, we simplify and divide. Now we got the answer, which is P sub 2 is equal to 600 kilopascal. Therefore, the new pressure if the temperature increases to 1200 Kelvin is 600 kilopascal.